Welcome to the capacitance video. In this experiment, we'll be measuring the capacitance of parallel plates at different separations with and without dielectric material and finding the permittivity of free space. To start, we'll connect the circuit. Place a T connector on the function generator output. This way we can monitor the signal we drive the circuit with as well as its response. One end of the T should go to channel 1 of the oscilloscope with a BNC cable. Attach the red positive pin of the other end to the resistor box. Attach the other resistor box terminal to one of the plates, and attach the other plate back to the negative pin of the function generator. Finally, attach the oscilloscope channel 2 across the two plates, making sure that its negative pin connects to the negative pin of the function generator. It may also be useful to connect the external trigger for maximum signal stability. To do this, you can connect the function generator TTL output to the oscilloscope's external trigger input and set the trigger to external. You should also choose an appropriate frequency, something below 15 kHz, set the offset to half a volt, and make sure you're outputting a square wave. Position your signal conveniently on the oscilloscope. Choose a resistance on your resistor box that will let you see the exponential decay curve even if the plates aren't very close together. Separate the plates by about 10 centimeters so that we can measure the parasitic capacitance in the system. Using the cursor function on the oscilloscope, measure the voltage on the capacitor at the beginning of the exponential decay. Divide this value by E and record the result. Switch to cursor 2 and find the point where the decay reaches the value you just calculated. You will want to record the time difference from the beginning of the decay to this point. If you have set cursor 1 at the beginning of the decay and cursor 2 at this point, you can look at the delta T value on the right side of the display. In exercise 2, we'll be using different thicknesses of paper as dielectric to fill the capacitor and measuring the capacitance at each separation with and without dielectric. Can out 5 sheets of paper. Insert them between the plates. Close the plates on them, making sure that the plates are tight but not pressing. That is, they will not close further when the paper is removed. Find the time it takes for the voltage to decay to 1 over E of its original value, and use that to measure the capacitance as you did previously. Remove the paper, being careful not to change the plate positions. Measure the capacitance again. Use calipers to measure the thickness of the paper. Only use the knob to close the calipers to avoid applying extra compressive force. This time, put 10 sheets of paper between the plates. Repeat the process, measuring capacitance both with and without the paper, and measuring the paper thickness. Repeat this for 15, 20, 25, and 30 sheets. Don't forget to measure the diameter of the plates so that you can calculate their area. In exercise 3, we'll be measuring the dielectric constant of glass. Put on work gloves whenever handling the glass. Gently place the glass between the plates and measure the capacitance again with and without the glass. Don't forget to measure the glass thickness. Thanks for watching the capacitance video. And remember, if you think you've been overcharged for a purchase, try lowering your capacitance.